All right, ladies and gentlemen, welcome back. This is chapter 3.4. And in 3.4, we're introducing the idea of slope and rate of change. And in this particular series of videos, you're going to be able to calculate the slope given 2 points. And you'll also be able to say whether a line is rising, falling, horizontal, or vertical based on its slope. So let's jump in and talk about what is the slope. Well, the slope of a non-vertical line is the ratio of the vertical change, also known as the rise, to the horizontal change, also known as the run, between any 2 points on the line. So that's there's some jargon there. What the heck does that mean, right? Let's draw a picture and talk about some what this really is. So if we have a graph with a line, the idea of the slope is to tell us how steep this line is, right? It is a number that represents steepness, okay? It is a number that represents steepness. And we represent that steepness by showing the change in the x value down here. So we have 2 points, and we look at the difference between the x values of this point. So we'll call this point down here x1, y1, and this point up here is x2, y2. Down here, this length is x2 minus x1, right? So it's this distance minus this distance. And over here, it's this distance on the y's minus this distance on the x, otherwise known as y2 minus y1. So we find whatever this distance is, and we these two distances, and that tells us how steep of a number it is. So we have a formula for that. M, which represents the slope, is the y2 minus y1, which is this number minus this number, divided by x2 minus x1. And again, this is telling us a number that is representing how steep something is. If the y differences is very high and the x differences is very low, we're going to have a fairly large number here. So a large positive number means that it's increasing very sharply. But if it's a smaller number that's positive, it's going to be increasing a little less steeply, like a small y and a large x. It's going to be a gentle slope, kind of like this right here. If it's a negative slope, then that means it's going to be going down. So slope is representing steepness, right? It is how steep a line is when graphed, okay? And we have a formula for it, y2 minus y1 over x2 minus x1. So let's do a couple of examples where we actually calculate the slope. So we have 2 points here, and we could go as far as actually graphing these 2 points, right? 6 is up here, and -4, 2 is right there, and we could kind of like count to do that. But what I want to do is use the formula for these. So the formula is y2 minus y1 over x2 minus x1. So looking at my points, this first point is x1, y1. This second point is x2, y2. So I'm going to take these values, y2, plug it in right there, 2, minus 6, over -4, because that's my x2, minus 2, because that's my 2. And then I just calculate this. This is 2 minus 6, which is -4. And this is -4 minus 2, which is -6. And when we reduce that, I get 2/3. So the slope of this line is 2/3. Notice that that's a fairly small number. It's positive, so it's increasing, but it's not increasing super fast. Again, this means that I'm going up 2 and right 3, right? From a point. If I go up 2, right 3, up 2, right 3, I end up on the next point. All right, so the next example. Again, I'm going to use the formula y2 minus y1 over x2 minus x1. So here's x1, y1. Here's x2, y2. And I'm going to plug the numbers in and simplify. So this is -1 minus 5, 6 minus 3, which is -6 over 3, or negative 2. So notice now we have a negative number, right? And that means that this is going to be a slope going down as we do that, right? And just a quick graph of that. 1, 2, 3, 1, 2, 3, 4, 5 is right there. And then this is 6, negative 1. Notice that the graph, the line connecting these points is going down as it moves to the right, whereas this one was going up, right? It's also steeper than the last one. Let's keep going. So here we have negative 2, 4, and 4, 4. Again, my formula, y2 minus y1 over x2 minus x1. I get 4 minus 4 over 4 minus negative 2. Notice here that since that's a negative, this is a minus from the formula, and then negative 2. So it's minus negative 2. 4 minus 4 is 0. 4 minus negative 2 is 6. So this is 0 divided by 6, which means it is 0. So my slope is 0, meaning it is not steep at all. And let's graph these 2 points, and you can see the reason why this comes out to be 0 is because this is a perfectly horizontal line, right? Horizontal lines don't change. They're not going up or down. So it just stays 0, right? It has this value. And remember from a couple of lessons ago, right? This means y equals 4. That's the line, the horizontal line, y equals 4. So it has a slope of 0. Finally, we've got one last one. Again, the formula here, y2 minus y1 over x2 minus x1. This is 1 minus 5 over 3 minus 3. And notice that this time, when I do this, the 0 ends up in the denominator. And we can't divide by 0, right? That's one of those illegal rules in mathematics. We can't divide by 0, which means this is undefined. So we draw a 0 with a slash through it. It is undefined. We can't divide by 0, so that's undefined. And again, why does this happen? Well, take a look at the graph. We're at 3, 5, which puts a point there. And we're at 3, 1, which puts a point there. This is a perfectly vertical line. It has an undefined slope because it's not increasing or decreasing at all when it goes left or right. It's just straight up and down. It's a vertical line. So horizontal lines are going to end up with a 0 slope, and a vertical line is going to end up with a negative slope, or excuse me, an undefined slope. Okay, I've got some problems that I'd like you to do back on your canvas, so if you could go do those practice problems by yourself, and then come back in the next video and check your answers. We'll see you in just a minute.